Hey guys, it's me. This video is going to tell you, I'm going to do a problem very similar to problem 2 on homework 4. Okay, just to give you guys a little bit of help. Once again, you guys are just absolutely rock stars, and so I have complete confidence in you in every way. But this is just a little bit of an extra hint. Okay, so problem number 2, we're going to do a similar problem. We're just going to change around the numbers. So it says, suppose a cannonball is fired at 30 degrees above the x-axis. So we'll change it to, why don't we change it to 60 degrees, okay? So we'll say a cannonball is fired 60 degrees above the x-axis, okay? With an initial velocity of 20 meters per second is the question. So we'll change that to, why don't we change it to, let's try 30 meters per second. Why not, right? And we'll answer the same question. So that means that, let's see, here's our cannon. We'll just draw like an arrow for it because, as you guys know, I can't draw so well. And we'll have this be 60 degrees, okay? And we have an initial velocity, so that's our initial velocity vector. And this is equal to, we change it to 30 meters per second, right? Okay, awesome. And here's our x-axis, and here's our y-axis. All right, so part A says, what is the maximum height that the cannonball will reach? And then it says, at its maximum height, what is the ball's velocity? All right, so now this problem, before we start anything, we have to think about what this kind of a question is asking us. And we have to consider, of course, that this is a two-dimensional problem in the sense that we have to worry about both what's happening in the x direction, right, and what's happening in the y direction. And of course, those things are independent in the sense that acceleration in this direction won't affect anything in this direction. But as a whole, obviously, what we see is the combination of the two. I'm not sure if that makes sense, but it will as we go. So remember how we said that it doesn't matter how much you push it. If you throw a ball straight out, it'll hit the ground at the same time as if you just drop a ball straight because you're just creating a horizontal velocity, right? So the only thing we have to worry about when we want to know how much time it's going to take for this to hit the ground is the y velocity. Simply because if there wasn't an acceleration at all, it would just keep going forever. So in other words, if I throw a ball up in the air, right, straight up in the air, with the same y velocity as we have in this problem, it would take the exact same time for it to hit the ground, simply because gravity acts upon it the same way. I'm not sure if that makes sense right now as I've said it, but it will make sense as we go through the problem. If it's not so clear, of course, pause, rewind, watch it again. But basically, just consider that whatever this y component is upward, if I were to throw up a ball straight upward with that same velocity, it'll take exactly the same amount of time for it to hit the ground as it will here. So to get to the top and then back down again. Okay, so in this case, let's find out what this y velocity is, simply because if we want to know how long if we want to know, the maximum height, right? So the best way to find that maximum height, right, is to consider that what do we know about when it hits its maximum height? Well, we remember from class, right, that when you throw a ball straight up in the air, it kind of hangs for an instant before it starts falling back again, right? So at that point where it's at its maximum height, okay, so this is y max, okay, the y velocity has to equal 0, okay? Because if I were to just throw it straight up and down, right, there's that point before it turns around and starts going down again where it just kind of hangs in midair and has 0 velocity in the y direction. So the only velocity up here, right, so at this point, v total is just the x velocity, okay? So really when I ask what's the maximum height that the cannonball will reach, what I'm really asking is how high is the cannonball when its y velocity is 0. Okay, so think about that, rewind it, watch it again, and I promise you it'll make sense. But it's just take my word for it for now. It's true, like, just because it's that moment when it hangs in the air. So what we want to find, right, is the amount of y distance, the height that it's going to take, right, for it to get from its initial y velocity to the 0 meters per second. So let's find what this initial y velocity is. It's the initial sub y. And in order to do that, of course, we have a right triangle here, right? So you guys can do this in your sleep by now. This is equal to the V naught. This is a vector. We'll do that V naught times sine theta, right? Because it's opposite. And you guys can, figure that out and do the math, but that's what that equals. So then we'll say over here, we'll go V naught sub y, initial, right, is equal to V naught sine theta, which is just 30 meters per second, right, times sine of 60 degrees. And sine of 60 degrees, I believe, is radical 3 over 2. So it's going to be times radical 3 over 2. Check that, but it should be right. So this equals 15 radical 3 meters per second, okay? And that's the upward velocity, all right? So if you think about it, right, we can treat this again as though I was just throwing a ball straight upward without any X issue, because all we care about here is the height. We're not asking about anything in the X direction. So I can treat it as if I just threw it straight up and down with an initial velocity of 15 radical 3 meters per second, because this is the velocity in the Y direction, okay? Now again, I want you guys to consider this, think about it, and then, pause it, rewind, make sure it makes sense before we move forward. Or come and talk to me if it doesn't make any sense, okay? So now, all I need to know, if you realize like where we're at here, is the amount of time that it takes for the ball to change its velocity from 15 radical 3 meters per second to 0 meters per second in the Y direction, and that'll give us or how the Y distance that it takes for it to get there, right? And that'll give us our answer, right? Because we can treat this, like I said, if I were to throw a ball straight upward with this velocity, that moment where it takes that pause at the very top is going to be the height that we're looking for. So I can just treat it as if it's a simple one-dimensional problem in that sense, okay? So I'm going to look at my kinematic equations over here, and I'm going to think which one I should use. So I want something, of course, that's going to have my velocities, because I know my initial and my final velocity, so that's good. I need to find the distance, because that's what I want to know. So I want to find d sub y final, or v sub, we'll just do this. We'll go d sub y, we'll say max, okay? Because that's when it's at the very peak, and that's what I want to know. I also have the acceleration in the Y direction, because of course the acceleration in the Y direction is just the gravitational constant, which, as you guys know, is 9.81 meters per second squared, right? So knowing that, I look at my equations and I'm going to choose to use, we'll use this one. We'll use this equation. V final squared equals V initial squared plus 2a times the distance. So that'll be, in this case, Y final minus Y initial. And these, of course, are Y. These, of course, are all the Y direction, because we're not dealing with the X direction right now. Okay, and again, I know I'm going kind of fast here. So if at any point you feel confused, of course, pause, rewind, email me, ask me. I love it when you guys come and are like, Ms. Mizrachi, I need to understand this. It makes me so happy because you guys are just brilliant, and I love discussing this stuff with you. Okay, great. So the final velocity, right, what we're trying to look for here is when it equals 0 meters per second. So this is going to be a 0, right? The initial velocity that we're dealing with here is when it's 15 radical 3 meters per second. And plus 2, now of course our A over here, right, is just going to be negative, right, 9.81 meters per second squared, because in this case the velocity is decreasing, and if the velocity is decreasing, you're going to treat your acceleration as a negative, just because it's pulling it down. If you think about that for a second, it'll make sense. Just stop, rewind, and check that it's kosher. So we know our Y final is what we're looking for, so times Y final. And our Y initial, we'll call it 0, because we'll call this point here 0. So we'll just say Y final. And look at that, we can solve this, can't we? It's pretty easy, not too bad. So not too shabby, not too shabby. We'll just say Y final equals, we'll subtract 15 radical 3 from both sides, right? You guys know how to do this. You can do this in your sleep by now, right? 15 radical 3 meters per second. So, and then of course, so you're going to say, and then we're going to divide by this. So long story short, when you do the algebra, which you guys can totally do yourself, you get negative 15 radical 3 meters per second divided by 2 times negative 9.81 meters per second squared. All right? And of course, oh, I apologize. This is velocities are squared here. Sorry about that. Yes, this should be squared. So you notice that there's something wrong with the units, right? Okay, good. So I'll plug this into a calculator. Well, you know what? I'm not going to even do it. You can do it yourself. Plug this into a calculator yourself, and you'll get yourself an answer. But I do want you to notice, right, that the units here work, because we have a meter squared divided by meters, so you get meters. Second squared divided by second squared, they cancel. So you will get meters, which means that our units work, which means that we're at least doing it. It's a good check that we're at least in the right direction, if nothing else. Okay, good. The next question is going to be how long before the cannonball hits the ground. So we now want to know the time that's passed, right? Well, we know the distance. We just found it. Or no, actually, there's even an easier way to do it. We know the final velocity and the initial velocity in the y direction, right? Because remember, this is just the time when the velocity equals, the y velocity equals 0, because it's at that peak. So we can just say that the y velocity final equals the y velocity initial, right? Plus acceleration times time, which in this case is just going to be that final velocity, which we said was, we said was 0 meters per second, right? Is equal to the initial y velocity, which is 15 radical 3 meters per second, right? Plus we'll say minus, in this case it doesn't matter, minus 9.81 meters per second squared times time. Now we just solve for time, right? And we get the time. By the way, we're getting negative values here, and it doesn't really matter. So just know to change these to positive values if you want to have that. So we can say, because basically what we're doing is we're assuming that downward is the positive direction, which is why the distance upward comes out negative and the time comes out negative. But when you do it, you should obviously change it to positive, just because you can't have a negative direction or a negative time in this application. So even though I'm using it as a negative 9.81, your answer, you can just drop the negative sign, just because physically it doesn't make sense. So that being said, our time is just going to be 15 radical 3 meters per second divided by 9.81 meters per second squared. Not too shabby. Look at that. Pretty nice. I'm going to actually go ahead and just solve this. So we're going to pretend this is about 10 on the bottom, just because I don't have a calculator on me and I just, want to do it in my head. So t is about equal to 15 radical 3 divided by 10, which is equal to 3 radical 3 over 2. All right, seconds. Not too bad. Notice again, the units are beautifully working out and we're good to go. Beautiful. Okay, so let's do part B. How long before the cannonball hits the ground? So again, we're going to consider what this question is asking. It's saying, how long does it take for it to get from here all the way to its peak and then come back again down over here, right? Now, again, there are many ways you can do it, but I like to think of it as how long does it take for a ball thrown straight up in the air with this initial y velocity, right, to come back down again. Because remember, it'll take just as much time if I throw something, like if I throw it with an angle, as if for it to go up, pause, and then down again, as if I were to throw it straight up in the air with this same y velocity. So all I can say over here, right, is, I apologize, we just did this, I'm so sorry. So as max, how long before the cannonball hits the ground. So this is where I'm skipping around here, I really apologize. I accidentally just did the first part of B. So we just found the amount of time that it takes for it to get to the top. And now if I want to know the amount of time for it to come back down again, all I do is double that, right? Because it takes this much time for it to get to the point where its y velocity is 0, which means the top of its peak. And it's exactly going to take exactly the same amount of time for it to come back down again. So the time total, right, the time when it gets to all the way over here is going to be all of this. So it's going to be, we'll say, time max, right, when it's at its max, like height, times 2, which is just going to be 3 radical 3 seconds. All right, if any of that doesn't make sense, please pause, rewind, and ask me about it. All right, so now we want to know, we'll go back to A again. At its maximum height, what is the ball's velocity? This is a little bit of a trick question, because we said that at its maximum height, what's the y velocity? Well, it's 0. So all we've got to deal with at its maximum height is its x velocity, right? Because all the y velocity is disappearing. It has disappeared, which is why, of course, it's able to turn around and come back down again, right? So it's just like up and down, and all that so really, if you think about it, since all the y velocity has been lost to the acceleration, or in this case, deceleration of gravity, right? All that's left over is the x velocity. So we can say then that velocity at max height, at, we'll say, y equals max, is just equal to v sub x initial, which equals v sub x final, which is v sub x all the way through, because velocity is constant, because there's no acceleration in the x direction, right? So what's that velocity that's the x direction? Well, it's just going to be v initial, right, cosine theta, because now we've got the adjacent angle, or the adjacent side. So this is just equal to 30 meters per second. I think cosine of 60, let's see if I can remember my geometry. I think cosine of 60 is a half. If I'm wrong, I really apologize. So this is going to be 15 meters per second. Not too bad. And that's going to be the velocity at the top of its projection, and that's its x velocity over here. So we'll just say v naught sub x equals v sub x always equals constant equals 15 meters per second. Okay? Awesome. I hope you guys can see all that. Okay, good. So we can do now the rest of it's really very, very easy. So we want to know how far horizontally will the cannonball travel before it hits the ground, right? Well, to do that, we already have the x velocity that maintains, right? And we know the amount of time that it has to travel. So all that I really need to do is figure out how far I can get in the x direction in the time that I have to stay in the air. So that means, of course, now remember when I have constant velocity, velocity is just the distance covered over time, right? If it's not changing, velocity is constant here in the x direction. So since we're dealing with the x direction, we could say that the horizontal distance, right? Can you guys see? Yeah, you can. Is equal to the x velocity times the total time that it spends in the air, right? Which is just 15 meters per second times 3 radical 3 seconds. Of course, these seconds go away. And I get 15 times 3 radical 3 meters, which is 15 times 3 is 45. So I get 45 radical 3 meters. Sorry, I'm losing my voice a little bit. And that's going to be the distance as which it hits the ground. And if you think about it, it makes sense because we found the time total as the distance that it takes for it to go bop, 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 all the way to the top and then bop, 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 all the way down again. So this is going to be if it's going constant velocity, it's going at a constant velocity in the x direction. So with that constant velocity, what we found here is the amount of distance we can cover in the amount of time that we're allowed to have in the air. So that's just 45 radical 3 meters. Hopefully that makes sense. And we've got just one last question, which again is a little bit of a trick question if you think about it, which is what is the cannonball's final velocity as it hits the ground, right? Well, this is a trick question because if you think about it, right, well, I'm just going to tell you the answer is that it's exactly the same as it left with, except coming in. And if you think about it for a second, it makes sense because both of the components are the same if you think about it. Because look, the x velocity, does that change at all, the entire trajectory? No, we know that's constant because there's no force acting on it. Now the y, right, there is a force acting on it, but at first it slows it down, and then it has exactly the same amount of time and exactly the same amount of distance, right, to speed it up again. So we're going to have it at the end of the trajectory, we're going to have the y final, or excuse me, the final y velocity, right, so the velocity sub y final, right, is going to equal negative, right, y velocity initial, because it's just this, but in the opposite direction. What comes up must come down with the exact same final velocity. But the x velocity, right, is exactly the same. So v sub x final equals v sub x initial. So if we draw our new vector coming this way, right, we get kind of an opposite of the triangle that we had before, right? This is going to be 60 degrees. Isn't that beautiful? So that means that the final velocity here, right, means that v final equals negative v initial, right, which is just going to be negative 30 meters per second. But I wouldn't think of it that way. I would think of it as negative 30 meters per second in terms of where it's coming y, so in the y direction. So I would say, you could say its final velocity is 30 meters per second, 60 degrees headed toward, like 60 degrees downwards towards the ground. So really, if you write this, this answer as, if you write it as 30 meters per second, and you say 60 degrees above the diagonal, and you say like, you know, you would say 60 degrees, excuse me, above the x-axis, in the negative y direction. That's what I would say. All right, if you want to write points here, I'm sorry, I'm losing my voice a little bit. And so if you see, you know, really that problem, it looks kind of icky in the sense that there's a lot to think about, but notice how it's really, really easy once you understand what's going on. So if you look at this problem right away and you're like, okay, my acceleration is only acting on my y, so when I want to know a time thing, I just have to worry about the y direction because that's the big limiting factor. And you just realize your x velocity is constant the whole way through, then everything else is just kind of easy. It just kind of solves itself. So the big important thing here is to think about the physics and understand what's going on, and only then manipulate the math to make it bend to your will. I really like this problem, and I hope you do too. Again, it's hard. I suggest that you watch this video a few times and kind of practice it a lot, because this is very similar to the kind of things that you're going to see on the exam. And I know you guys are just going to do amazing, and I get so much knowledge from you. It's unbelievable, and I'm really excited to see you tomorrow. Have a good night.